In lesson 11, we are still talking about proportional relationships, but instead of just looking at their graphs, we are now going to look at their equations. So in lesson 10, we looked at graphs, and remember in the graph, you could tell it was a proportional relationship if it went through the origin of the graph, which was 0, 0, and if it was a straight line graph. So this table here shows us the number of people who can ride in a roller coaster depends on the number of cars on the roller coaster. So how many people can ride in one car and then in 10 cars? So there's questions underneath here that we're going to have to answer to get to that. So for part A, it says find the ratio of the number of people to the number of roller coaster cars for each set of data in the table. So you want to read this. The first thing listed is going to be your first number. And remember, before that, a ratio is a fraction or a division problem. So the first thing listed is the number of people, and then it says 2, the number of roller coaster cars. So if I look in the first one, I have 18 people divided by 3 cars. And the next one would be 30 divided by 5, 36 divided by 6, and 48 divided by 8. So if I do the math on all 4 of those problems, I'm going to get 6. So the ratio of the number of people to the number of roller coaster cars is 6 in each set of pieces of information there. Are the ratios of the number of people to the number of roller coaster cars in a proportional relationship, and explain your reasoning? Yes, they are, because we got the same answer every time we did the division problem. So yes, and we got the same answer, got the same ratio each time. All right, how many people can ride in one car? Well, that answer is 6, because when we do that division, we're finding what's called the unit rate, how many per one. So there's 6 people in one car. And the next question says, what is the constant of proportionality for the data in the table? That is also 6. So constant of proportionality and unit rate are the same thing. How many per one? Explain how you can find the number of people that can ride in a roller coaster with 10 cars. Well, if I know that 6 people can ride in one car, I'm going to times 6 by 10 since I have 10 cars. And then write an equation to represent the number of people y that can ride in the roller coaster with x cars. So y equals 6 times x, which is the number of cars. So if I had 50 cars, I could do 6 times 50 to figure out how many people could ride in that car. All right. The problem on the previous page is shown using a table. You can represent this situation with both graph and equation. So we had the table, we wrote the equation, and now they're giving us the graph. The graph represents the problem on the previous page. So that's what it would look like if we plotted those points. So here is what I just talked about in the last page here. The constant of proportionality is the unit rate, or the value of y when x is 1. So how many per 1? All 3 of those things mean the same thing. How many per 1? And we figured out that it was 6. And as you can see, they're showing here going from one point to the next. Every time I go up a car, so I'm plussing 1 going over on the number of cars, I have to go up 6 for 6 more people to ride in each car. So there's our equation. We wrote that in the last page. And if 2 quantities, x and y, are proportional relationship, then the ratio of y over x equals the constant of proportionality. So you want to write this down. Y over x equals the constant of proportionality. Okay, and then once we figure out that, once we do the y divided by x to figure out the constant of proportionality, we can turn around and put it in this equation. So y equals whatever that number is times x. So these are the two pieces of important information that you need to have written down in your notes today. All right, explain how the constant of proportionality is represented in the table, the equation, and the graph of the roller coaster. So in the table, we can do the y divided by x to get to the constant of proportionality. The equation is y equals the constant times x. And then in the graph, we have to go over 1 and up the constant of proportionality. So whatever that number is. So like in that graph, we talked about going over 1, we had to go up 6 because the constant of proportionality was 6. So on a graph, we would go over 1 and then up whatever the constant of proportionality is. All right. Next problem here, Jesse is making punch. For every 3 cups of juice, he needs 6 cups of seltzer. Represent this proportional relationship using a table, a graph, an equation, and identify the constant of proportionality. And what does the constant of proportionality represent in this situation? So we're modeling it here. So here is a table where every 3 cups of juice, we need 6 cups of seltzer. So that ordered pair is given right here. And if you, when you read this, the ratio of seltzer to juice, so seltzer is the top number in your ratio. So 6 over 3 simplifies down to 2 over 1, which simplifies down to 2. So then you can figure out other ordered pairs to make a table using that piece of information. So then we can graph. So they're graphing this ordered pair, the juice. Remember, it was y over x, and we had 6 over 3. So 3 is our x, so 3 was our juice. So that's why juice is down here on the bottom on the x-axis. So over 3 and up 6 for an ordered pair. And from last lesson, lesson 10, we know that a proportional relationship graph has to go through the point 0, 0. So then we can draw our straight line through that. And we can also write an equation. So we know that our constant of proportionality was 2. So we can write y equals 2x. And we already talked about in the graph situation here how x is our juice and y is our seltzer here because we knew this piece of information. All right. In the table on the previous page, what does the ratio 2 over 1 represent in terms of the problem? So 2 over 1 is 2. So 2 what? So remember here it was seltzer to juice and 2 over 1. So the top would be seltzer and the bottom would be juice. So 2 cups of seltzer to 1 cup of juice. Oops. And what does the point 2, 4 represent on the graph? So going back to this 2 over 1, remember it's y over x. So in this case, we would have 4 over 2 if we had y over x. So our y is our seltzer. So 4 cups seltzer to 2 cups juice. And which point on the graph can be used to find the constant of proportionality? We want to use where x is 1. So we go over to 1 and then we go up. We can figure it out there. So because we go over 1 and then we go up 2. So the constant of proportionality, remember, is y over x. So our y value is the up and down. So that would be 2. And our x is how far we went over. And that would be a 1. So, oh, and the ordered pair for that point, oops, is over 1 up 2. Use the constant of proportionality to write an equation to represent S, the number of cups of seltzer you need for J cups of juice. So S is going to equal 2 times our juice, because our constant of proportionality is 2. Oops, what can I keep? All right, number 6. Use the equation you wrote in problem 5 to find the amount of seltzer you would need if you have 15 cups of juice. So I'm going to have to do S equals 2 times 15. So S would equal 30 cups of seltzer. For a different punch recipe, the equation S equals 4C represents the number of cups of seltzer S that you need for C cups of cranberry juice. What is the constant of proportionality? Remember, an equation, the number that's being multiplied by that variable is your constant. So it's 4. And we can say the number being multiplied by the variable. And then here, a couple of last problems, two more problems. Kelsey can buy 2 pounds of apples for $7. Write an equation to represent the cost C for A pounds of apples. So C is going to equal, we have to figure out how much it is for 1 pound. So we have to take that 7 divided by 2. The cost per pound would be 3.5. And so we would do 3.5 times A for however many pounds. So if we bought 10 pounds, we would do 3.5 times 10. And then our last one, the equation M equals 32 times G represents the average number of miles M that a car can go on G gallons of gas. So M is miles and G is gallons of gas. What is the constant of proportionality and what does it represent in this situation? Well, the constant of proportionality is 32. And what does it mean? Well, G is 1, or G is gallons of gas. So if we had 1 gallon of gas, we would do 32 times 1. And that would tell us how many miles we could go. So this 32 means how many miles per gallon that this car could go.